Let's start then. So, welcome back, everybody. It's so good to see you back. Hope everybody's feeling good and being safe and healthy. So today, I have the webinar about the text mining and natural language processing, and I'll introduce you with the basic concepts, and then you're gonna practice the concept I'll be introducing with Python. So the goal of this webinar is to introduce with the basic concepts of the text mining and natural language processing, and see the horizons of collaboration between our department and the English language department for anybody interested in working together or solving common problems or problems on each side using the computational models and the knowledge the English department people have in linguistics. So before talking about data mining, we have just a quick definition for the mining. So the term of mining came from when the people dig the mountains and the hills to get like gold and silver stuff out of it. So so they mine. So they literally mine the mountain to get like interesting stuff out of it. So we have the term of mining is it's the process for industry of obtaining coal and other minerals from a mine, like gold and silver and other stuff. So the process of mining goes through very precise steps, like let's say algorithm, until we get the final golden doors out of it. So it goes with a selection of a dust and mud. So they crush it and then goes through filtering, melting. At the end, they add some chemical compounds to it to get rid out of the uninterested minerals of it to get the gold at the end of the day. So I'm just defining now the definition for the mining, then I'll go to the text mining. So just to define the concept as simple as possible to the members from the English department. And they might be also useful to our department, faculty members. So the steps for mining, it is the selection and cleaning and pre-processing and transformation and mining and evaluation. So we first select a pile of mud and dust, then we clean it, then we transform it, then we mine it like gold out of other minerals from the mud and dust. So then we evaluate like all gold that we got, how much it is pure. So when it comes to the computational terms like technology and internet and computer, so we have another kind of pile. So in the case of the gold, there was like pile of like mud and dust. Now we have pile of data. So you got big data term. You can hear it from everywhere. That is the data is being collected from all sorts of the resources over the internet. So we got, let's say this is the data center for the Google. So they got like trillions of data pieces. So it's also hard to read all of these data and get interesting insight out of it. Like imagine this is a mountain of data and you want to have gold out of it. So you actually need to mine it. So that's what we call it, data mining. So we mine the data to get something interesting out of it. So in the case of text and natural language processing, we have tons of data out there. So around 80% of the data over the internet is in natural language text. So the other 20% is video and images and the other sort of formats, data formats. So like sources of the natural text is ebooks, documents, web pages. You have emails, blogs, news, chats, academia sources, and like news and different kinds of sources that generates the natural language data on the internet. So for us as human, we just hard to read all that data and and get interesting insights out of it. We need computer, we need technology. So this is when the technology comes to play to help us dig that textual data and get interesting stuff out of it. So my outline is I'll define the problem we're handling with natural language processing and text mining. I'll introduce you with the basics of the NLP and the TM, text mining, and then gonna practice the concepts we will learn today in Python, just a live demo. Okay, so let's define the text mining concepts here. So text mining is a kind of data mining. So we have the big umbrella of data mining that we can mine any kind of data. Like you can mine, let's say, video files to get like interesting episodes from it. Let's say that you have a data set of like 1,000 videos. You want to extract the episodes that kids talk there, or there's some kind of special kind of conversation going on in the video, or you want to, or you have pictures. You have pictures, like you want to get something interesting from a data set of like millions of pictures. So, but here we're talking about the text, the natural language text. So the process here is to identify actually automatically and extract unseen information and data from the natural language text. So shortly, you have text, we'll turn it to insights and interesting information. So the simplest possible text mining would be the term or word frequencies. So if I take you here, we're gonna do a very simple text mining operation here. So let's go to, let's say we have Apple, okay? If we have Apple here, let's grab some text. Okay, so actually I wanted to get some pages about the fruit apple, but the Google gave me the Apple incorporation pages. So this is something, a challenge we have in the natural language processing, that computer still doesn't understand, catch our intention of searching and surfing the web. That's fine. Let's get just some text out of here. So let's say this text, we're gonna do a little bit of data mining and text mining on it. So if I go to here, so the basic possible data mining, text mining, is to find the most important words in a set of paragraphs of text. So that for that purpose, we have a lot of online tools that helps us to do that. So it's called Word Cloud. It's killing our time. Let's go. So Word. We go here. Okay, let's create one. Okay, so menu. Where's my text? So add, import. We can just paste our text here. Remove common words. No. Numbers now. Yes. So import words. So visualize. It will visualize the text I just given to it to give me the main, like the most important words out of it. So it just gave me these. If I go to some Okay, so it gave me the. So that is the most important word there, but we don't want that word. If we just give it again to it, so just do it again. Yeah. Okay. So here I'll say remove common words like the, and. Let's do it again and visualize it again. So you see here, so we just did that text mining. That is, we just found out of this piece of text that is written in a natural language, right? It's in English, right? So we did some text mining. So let's say this was our pile of text. Then we gave it to this web page, and it gave me this web page is a web application. So it gave me every word and its frequency, like how many times it has been mentioned in that text. So the word of apple 27 times, company 12, computer 9. So you can see here like the biggest number, the most important word in the text. So this is a basic text mining task possible. So so in this task, we're looking for the, let's say, the topic of the text. So if we give the whole text to it, it'll give us something different, right? Maybe another word will pop up over the Apple word or the company word. So this is something simple to do in text mining. But we're gonna talk about more sophisticated sort of text mining applications. So we got other names over the internet. If you surf the internet for after this webinar for some like articles or maybe papers, you'll encounter other terms that I wish you not mix them up. So the text analytics is when you have a big text data and you want to do text mining. So you're going to use machine learning algorithms. So when your text data is big, it's called text analytics. If you're just doing natural language processing, okay, so you want to, let's say, to find all the objectives in the text, or to find the stem of all the words in the text, then you're doing natural language processing. The other term is information retrieval, is when the data being text or other format of text being indexed and use it for let's say web search engines or other applications. So a text mining interaction with other fields of science. So here in the middle is the text mining. So we got other fields of science we needed to do the text mining test. So this is, you see this circle here? So in the middle is the text mining. So it overlaps with the computational linguistics. So that's why we invited the English department faculty members to get introduced with these concepts of natural language processing and text mining, and to see the possible research collaboration we probably going to do together with our department. So we got artificial intelligence and machine learning, and it is pretty overlapped with the text mining. And then data mining, the big umbrella, and then databases, library and information sciences like indexes for libraries, for books, for journals. So they do overlap. Yes, so natural language processing is overlap between the computational linguistics and the artificial intelligence and the text mining. So everybody needed actually, and they do work on it. So the people from the English department can think about computational linguistics as a tool to do natural language processing and for the interest of their field. And I'll briefly define this term of computational linguistics for the people from English department. So so insights to mine. So for example, some stuff that text mining, let's say, applications do for us is, for example, you have in news streams, like you have 100,000 millions of news articles. So using the text mining softwares and like applications, it can give you quickly all the name of the people there and places, or the date and time there, events there. Even it can group the let's say news articles or documents by topics. So I did work on the BBC data set. It was like about 9,000 documents there. So I did cluster them by topics. So it gave me 5 sets of documents for different 5 topics: sport, technology, business, politics, and entertainment. And also it can classify. So whenever you need to find the opinion of the customers, let's say in product review, you can use the text mining algorithms and softwares. So these are the potential list of text mining applications. So I did group them under different kind of applications. So for technology applications, we use text mining algorithms and softwares to do information retrieval, to do web search engine. For example, you search for word of Zaho in the Google, so it'll give you specific web pages. So why those pages and not others? So they use text mining. Language detection, when you talk to, let's say, Siri on your iPhone, so it detects your language. And speech recognition and fraud detection. So somebody will send you an email and you can't find it, and then you just find out it has been sent to the spam list in your Gmail, let's say. So how that happens? So they use the Google company, they use text mining to do that. Social media analysis. So let's say there's a post on the internet or a trending hashtag on the Twitter. So the companies do a social media analysis to see like how people interact with those trending, let's say, hashtags on the social platforms. Complex question answering. These also the question answering is software's applications. Some companies, they do have robot rooms when you chat with a robot, not an actual human, and you ask your questions and it gives you the answers. So they use text mining. Also in the social applications, social sciences, also again we have the social behavior analysis. Digital humanities, like libraries, they can index the libraries very easily. Let's say we have 10,000 of ebooks in our, let's say, university library. So how we can group them in topics and in majors. So we can use text mining applications. You don't have to do it manually one by one. Computational sociology, if you have texts from talking about the people, so you can analyze it too. And machine translation, so Google Translation is another application of text mining and natural language processing. So it comes to the business applications when people make money out of the text mining applications, NLP. Recommendation systems, when you go to like Amazon or eBay, so they recommend products to you. So on what basis they do that? So they use partially text mining and other also data mining and machine learning algorithms. Topic opinion mining. So I used to work with a team in Brazil. So they had a data set of meetings for people from different companies. So they asked me to help them with their research for clustering their documents, interview documents by topics. So I did cluster and group their documents by topics they have been talking inside those documents. So trends and novelty mining. So for example, you have articles about products, or customer reviews. You can get ideas like what to produce next in your production chain. So you can find the trends and novelty through the product reviews. You got business intelligence, risk management, customer service care, relationship analysis, or all just list is too long. So academia. So we do knowledge mining. We do the topic opinion mining, to trends and novelty mining. Let's say in a given field of science, let's say English language or computer science or chemistry, you can, if you have a data set of papers, you can find out what people are looking for. What is the next topic you need to work on? Also, other applications, we have security, crimes, elections, healthcare, and the list is just too much long. So in general, we have descriptive applications and predictive applications. Descriptive is when you have your data and you mine it to get something interesting. Predictive applications, when you predict something unseen and just coming on your way. So for a given company, let's say to predict what the next product would be, let's say, for example. So I just defined the definition of the text mining. If there are any question, I'll be happy to answer so far till here. If now we can just keep going. So let me know if there's any questions for the stuff I just defined. Okay, no questions. That's fine. So let me keep going then. So let's see how we do text mining, the steps. So as any sort of data mining branches, we do text mining in 3 steps. So you have to collect and retrieve your data. You have to have some data in your hands. Then you do pre-processing, and then you do data mining, the actual analysis of your data. So let's say we have a set of it says news articles, and we have to analyze it. Let's see, to find the verbs, all the verbs in those documents. Verbs refers to action words, right? So what people do, what's happening in those news articles. And then let's say you'll mine your pre-processed data, like to say what are the most happened actions in the news. Let's say what is the most happening thing or event that globally you can find it through the set of news articles that you have in your hands. Just say the frequency, just the simple stuff. So then you can visualize your output. So we don't need to mix the text mining with information retrieval. As I said, it's just the first step you have. And then information extraction, also it's a pre-processing. Then the text mining comes itself. So none of them can replace the text mining, but we need all of those 3 steps. So we have these classic, very traditional steps in the data mining, and it also applies to the text mining. So first, you have to have some data in your hands, right? So let's say you have news articles from BBC, let's say. So do you want to analyze all those news articles or just a subset of it, like the set that talks about the sport or politics or technology? So that's your decision or what your company needs. So you do data selection. So you might select subset of your data, and then you have to clean it, right? So as I just defined at the beginning, when the people go to the mountain, so they have to clean the dust and mud they get, right, before getting the gold out of it. So we have to clean our data. There should be noise there. There's always noise there. Like let's say in the case of the text mining, you have punctuation symbols like question marks and quotation marks and all those sort of noise. We have to get rid of it. So then you have the text transformation. So for the computer to understand that text, it has to be converted to numbers. It has to be converted to numbers. So that's when we do the data transformation. So we turn the text to numbers. I'm going to see it shortly, what I do mean by every step. Then we do mine our text data, like actually analyzing. So we use statistical models to infer insights and interesting information out of our numbers that represent our text. So, and then we evaluate our tasks. So let's say I group the news articles by topics. So how is my grouping is good? So there should be some evaluation. measurements that I have to use to measure like my task of grouping my news articles by topic, or if I have been filtering the emails to being spam or non-spam, so how that task of classification was accurate. So we need to evaluate, and this is just something very basic scientific step that you have to evaluate your test. Let's talk about selection of your data. So in the case of text data mining, so we select our data based on application domain, or let's say if you're working on a research problem, so you select a specific sort of data, text data. Or you're working for a company that asks you to do specific text mining task, so they have already their text data in their hands, so we're just going to use it. So what topic you select, so also it could be single topic or multiple topics of the text. So we get it from the web, from companies, by email, however, you just need to get it. And then the format, it can be plain text or non-plain text. So you might have tables of like hundreds of millions of let's say Excel tables that have text inside. So, or just plain text, like a essay or a book. So this, it might be Word, PDF, HTML. So it can be any kind of data format. So the text corpora or corpus, we have different kind of them. So let's say by topic, it happens that the topics do not overlap. So let's say you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You got 11 documents. In this case, they're not overlapping. So it's just some random text documents. Or they could be categorized, let's say, by topics already. Or they overlap. Let's say these are the news articles from the Reuters. So they do overlap. So let's say there is here this dot. Let's say it's a news articles that talks about the technology. It's inside the technology topic, but it talks actually about how technology being used for the business purposes. So it's also inside the business circle of topic. Or it could be temporal, that when the time series analysis from statistical analysis comes to play, let's say you have a live stream of tweets and you need to analyze them to get insights out of it. So you have the parameter of the time. So to consider, then it is temporal. So these are different possibilities of the nature of your text data set, how it looks like. Now we come to the data cleaning, text cleaning and pre-processing. So, okay, so for this step, we are using the natural language processing. So that is a branch of artificial intelligence. It helps us to understand the language, to interpret the language, and manipulate the language, and optimally to generate a human language. So NLP, it needs help from computer science and computational linguistics to do its job. So for example, when you use Siri or use Amazon Alexa or OK Google, they do, all of them, they do natural language processing behind the scenes. So the steps, the pipeline of natural language processing is here. So when we do cleaning, we do delete and omit the punctuation marks, numbers, stop word removals, and we do handling structured content of documents. Let's say if you have tables in your Word files, so how would you turn it to plain text? And most of the times we need deep language analysis. For example, we need to find the verbs in the text, the nouns, adjectives, adverbs. So the way that people do NLP, it's either rule-based or knowledge-based or statistical models. So it has these steps. So we can go with the raw text at the beginning, this is the NLP pipeline. It can give us the sentences. So you have, let's say, a book. If you pass it to the NLP pipeline, it will give you a list of sentences in your book, or a list of, let's say, words, or a list of tagged words that telling you what is the type of each word, being noun, verb, adjective, adverb, or other kinds of words. It can also give you entities, like telling you all the name of the people there in the book, name of the places, dates, and other kind of text units. Also, it can give you the relations there, like Azad chasing the cat. So we got chasing, we got the axiom of chasing, Azad, and cat. So it can tell you, okay, there's a relation there between cat and Azad. That's the chasing. So it can also give you that piece of information. And then it's going after that. That is the semantic analysis that is still not a typical part of the NLP pipeline, and that is what people are working on it. And technically, me, Dr. Ismail, I'm working on this part. I'm adding this part to the NLP pipeline when it tells you the semantics of the text. Like for example, when I type the word of Apple in the Google, it just gave me the Apple Corporation pages. So a whole list of them. So what if somebody is looking for Apple, like let's say why Apple is good for? So it's supposed for the Google to give at least a mixture of hits or results to the search of the word of Apple, right? But over the net are the most important. So people are not looking to see what is the fruit Apple is good for. It's not that common as being searched for what the iPhone Apple or iPad Apple is good for. So yeah, people are not going for their health, just or for the tech. It's okay. Okay, so here for the natural language processing, we have multi-levels. So we go with phonetics, phonology, and morphology, and syntax, and semantics, and pragmatics. So when we do NLP analysis on a text, let's say in English or Kurdish or Arabic or any other language, we need to analyze it based on different levels. So you might go just to the morphology level that gives you the words, or you might look for phrases and sentences. So you need to go to the morphology, or you might look for the relations, right, or sentences. So you will do the syntax analysis, or semantic, like what I do, like the actual meaning of the language unit size is smaller. So if you go with phonetics, you'll just have the sounds, right, like a, o. If you go for the syntax analysis, you will go with at least let's say 3 words, like Azad chasing the cat. So you need more than one sound, right? You need a chain of sounds. So what people do in NLP basically is the same level of analysis people do in the English department when they do natural language analysis of their research. So we got the levels I just defined. I will leave these here because I just defined them briefly here. So just need to save some time. So the idea is we just go with the typical levels of natural language analysis when we do the NLP, the computational way of natural language analysis. So the challenges people face when they do NLP is that the 3 most challenges unsolved yet that people can work on it in our department, let's say they can focus on it. So speech recognition. So when you say, hey, Google, when you talk to your Google Assistant or talk to your Siri or Amazon Alexa, so how it detects your language, the speech. So it's still unsolved, like optimally. And then you got language understanding the natural language. So when you talk to Siri, sometimes it misunderstands you. That is a problem. When you have a robot need to talk to the people, so how it generates the natural language, right? So it's also hard and unsolved yet. It is solved partially. It did a great job, but still there is no that great results. And then why? Because some reasons for that. So the ambiguity of the language. So when you tell the Google, okay, word of bank, so it'll get confused, right? It'll tell you, okay, what you're looking for a bank of a river or like the money bank. And then the other reasons, the low resource of language. So in the case of Kurdish, you don't have that big Kurdish language corpus and corpora to work on. So that's one of the tasks we are doing in our semantic web research lab that I'll define it at the end of the webinar that Dr. Karwan and me have started and launched that research lab. And I'll tell you also briefly like what we do there. And then the unclear language. So yeah, I'm not you. So what does that mean? So, you know, misspelling. Tell your son to behave nice, for example. You know, it happens. So how computer can understand that? And then informal language. So see you too. You know, when I send that message, so it's just hard for computer sometimes to understand this. Or then or bad segmentations like hyphens, like how many. So what does this thing means here? Or punctuations like here's Mr. Zana's photo. So what does this dot means here? Is it a different sentence? Here is Mr. sentence. Another part of it is another sentence. So, and then word knowledge, like then use revealed his case. So what does it mean? What does it mean by that case? So a case of what? You know. So the natural language has many challenges. I'm just listing them here. And then multilingual corpora. And then you have unstructured tests. The data is unstructured. Talking about the natural language processing, why it's hard for computer to understand and generate and recognize our sounds, our natural language sounds. So it turned out to be some reasons there, like ambiguity of the language. Like talking about the bank, which kind of bank? The river bank, the money bank, when you talk to the computer. So you have to tell the computer more. You got other reasons, like some languages are not that well resourced, like Kurdish language. We don't have that big or many corpus of natural language in Kurdish. And recently we got some from the news mainstreams like Wudo and other sort of sources, but still not that big. And then the unclear language, misspelling language, informal language, like using emojis or, you know, idioms. And then like word knowledge. So when you tell the Siri or Amazon Alexa, like what happened to the case of that man, so which man, what case you're talking about, the Alexa will tell you. So you have to provide more knowledge to the computer, to your gadget. So here we have two fields of science that we can possibly work together. Our department is the Department of English Language. That is the Corpus Linguistics. I'll make it big. Okay. So there is a field of inside the linguistics field of the science that is called the Corpus Linguistics, when they do study the language as expressed in corpora, like text. Or it is the study of linguistic phenomena through large collections of machine-readable texts, so or corpora. So let's just make it simple for you. So we got a text data set, let's say hundreds of millions of the text. So we can analyze it to see how the language have been developed. So you can compare a data set of the text that you have in your hands from the year of 2020 and compare it with a corpus from the Shakespeare's work. So how the language looks different. They should be different, right? So we have the concept of language development when the language keeps changing, right? We also have it in Kurdish. The language just develops over time. So how the development is happening? You can do it that that work by numbers. So language variation. So you can compare the English language of Australia to the British or American English. So if you have texts in different, let's say, variations or dialects in text, you can use the computer applications or algorithms to help you find out the answers for those questions in your field of English language. That is called the Corpus linguistics. So when we mix up computer science with English language for the purpose of the English language department, they got two interests there. One of them is the Corpus linguistics, and the other one is computational linguistics. The other interest is most of them are for the Department of Computer Science. That is what we do, natural language processing. We do it to build smart machines, right? But we need the help of linguistics, the linguistics people to help us analyze the English language or other languages. So, but in this case, we have another branch of linguistics that's called computational linguistics, in which the techniques of computer science are applied to the analysis and synthesis of language and speech. So we also do analysis of the language using computer machines. This is another definition. So it's a scientific study of language from a computational perspective. So in this case, we're gonna come up with computation models that describe linguistic phenomena. So basically, a part of my PhD work was to come up with a computational model that models our semantic cognitive skill. So the purpose was, let's say in my work was, PhD work was to build a computer algorithm that understands the text the way we do the human, we do that. So I was serving all the cognitive models in the field of linguistics, and I was turning them back to computational models that I can code and make them algorithms out of them. So here we do come up with computational models, let's say, that mimics our cognitive skills related to the language understanding and generation and comprehension. Also, the linguistic people will get benefit from computational models to help them better understand linguistic phenomena people have in their minds, like how people understand text, how they memorize text, or the language. So I'll be happy to answer any questions now or later about these two fields from the English department people. So let's come to that transform of our textual data. I guess I have to go faster. So for transforming data, we have two options basically. So we either convert the text to the matrix or to a graph. So anyway, we have to come up with numbers. So computer just understands the numbers, right? You can't just feed the computer with a bunch of words and wait to get some results. So anything for computer has to be turned to numbers. So we have two way of transforming the text to the number. You either have matrix or graph. So technically, graph is stored in the matrix, but the way is different. So which data transformation you will select? So you either go with a matrix or graph. So okay, so it depends on. Let me see. It depends on your application. If you are working on the live stream text analysis, let's say you're analyzing the tweets over the Twitter in a real time, and you want real time results, you will not be happy if you go with the graph way. You will go with vectors or matrix way. If you need a deeper analysis of the natural language, for sure you will go with the graph way. That's special for the case of semantic analysis. So I've been used the graphs for a while because I need a deep analysis of the text. So it's based on speed and level of analysis. So in the case of the matrix, you have a list of words, and let's say a list of words, and in each document, how many times or the weight of that word in a given document. So how important is each word in each document? That will give you a matrix. In the case of graph, you will have, let's say, 2 nodes of 2 words in the text, and they do have edge between them if it happened to be in the same sentence, for example. So this is the 2 ways of representing the text. But how you will generate that graph? We got many options there, and I just had this paper. I did that paper with my supervisor, and we listed a literature review of how people have been using the graph theory to represent the text. And we came up with, we added our work on it, and then the future works in that paper you might refer to. Okay, let's do mining now. So for the mining task, you will try to discover text patterns in your data. For example, answering your question. And you're going to use machine learning approaches, their algorithms, and that all for discovering the answer for your main text mining question. So general talking, you're going to use the machine learning algorithms. So for the text mining, the purpose also you'll need the unsupervised learning algorithms, or supervised or reinforcement learning. So it depends on your application, but technically we can reuse those algorithms from the machine learning landscape. Okay, so the challenges when you do text mining, actual text mining, is the sparsity of the data. So it happens that the data space is sparse, so you get a lot of zeros there. Non-negativity, so you don't have negative numbers there. And then we need also side information to get your data space completeness better. So basic techniques, you might go with the word frequencies, or word coherence, collocation, or context aware. You got other advanced techniques in text mining people used to use, that is supervised learning. When you do text classification, like finding an email being spam or no, and then the frequent item mining, you can use it in the text as well, and association mining. Also unsupervised learning, when you cluster the text documents or you summarize them. And the example I'll be demonstrating is about the text clustering. And the approaches people use when they do text mining is either to have your text as a bag of words or graph-based, as I explained. Are you doing a syntax-free or syntax-aware of like text mining, or semantic-free or semantic-aware? For example, when you do text mining, do you care about the verbs in the text, or just consider them as nouns? Do you care about the semantics there or no? Oh, these are all aspects you have to consider. So are you doing in a level of term, phrase, sentence, document, corpus analysis? So what is the level of your analysis? And then are you using statistical models, graph models, cognitive neural networks? So these are also some tools like you will be using. When it comes to the evaluation, we use the basic data mining evaluation techniques. That is the precision and recall. So precision will answer the question of how many selected items are relevant. Let's say when you group your text documents into topics, so how many selected items in a given group is a relevant one. And the recall is how many relevant items are selected in a given group. And then you got the harmonic ratio between the precision and recall that will give you the F1 measure. So till now, I'm done with my presentation. I'll just be telling you that we have launched the Semantic Web Research Lab, me and Dr. Karwan. So you can check this website later, so to find out what we're doing there and what we have done, and what are our open problems that we would like faculty members in our department to join us for anything they see interesting, and then just show up and we can discuss about anything you have. So swlab.uoz.edu.kr. So yeah, you can check that website later. So we got everything about our lab. It's a research group lab. So I'll be showing a demo of doing a live demo of text mining in Python.